All right, welcome back. We are INFR3110U at Ontario Tech University, and it's Game Engine Design and Implementation for the Fall 2020 semester. And it's week one, part two of our broadcast, Programming Fundamentals. So let's think about this for a second, and hopefully you guys are back now from your break. Hopefully you are. Let's think about what we're talking about. I'm just going to bring up my participant panel so I can see you guys again. I picked up a couple people, it looks like, which is good. Some people joined us later. That's fine. The link for part one doesn't work directly from Canvas. Oh, that sucks. I'm so sorry about that. I'll figure that out, Daniel. Thank you for that. So you have to kind of click on it or grab it and post it inside of your browser, eh? I think there's another way of doing it with Canvas where you can add a video. And I've got to figure that out for you, so you can just click it and go. Yeah, so coding it can be a bit of a mess, and then game engines are really complex. I mean, if you want to use things like make a game engine, try to understand the back end of a game engine. Open up a game that you have nowadays in Steam, and I think you're going to see that when you look at the actual game that's been created from Steam, if you can actually open it up for modding purposes, sometimes understanding what other people have written and the design choices they've made from a coding perspective, or even their XML pattern that they've used, or JSON it can be quite challenging. All right, so again, think about the different operating systems that are out there and what they support. From an operating system perspective, I still think Windows is the best operating system for gaming. You can do some gaming on Linux systems right now, and there's limited gaming with Mac. But from a platform perspective, the PC platform is still the most popular amongst gamers. And it really depends on the demographic. For older gamers, let's say older than you guys, and maybe as old as me, they prefer consoles a lot of time because it's a pick up and go kind of environment. You don't have to worry about updates so often. And that kind of stuff. It's homogeneous. That means other people can play with you. They have the same system as you do. That kind of stuff. And some people prefer the Switch as an example because you can take it with you as you go. Lots of stuff. But can you imagine that these different platforms, they require a game engine to create code for those different platforms? And how can you make a game engine that's flexible enough to do that? And easy enough to understand when it comes to coding and adding things to it. So think about in terms of millions of lines of code that we're talking about here. How many millions of lines of code do you think we need for different kinds of game engines? You can see that starting off, as we move kind of from here up, right? As an example. We can see that we can get to 1 million lines of code quite easily as we move from one type of platform or operating system into a game engine. And you might think 1 million lines of code doesn't sound like a lot, maybe for you, but for me, when I think about millions of lines of code or 1 million lines of code, that's a crazy amount of code. And you have to know where to look, and that's one of the challenges. So from a best practice perspective, we're going to talk about that today. Commenting is really important. We're going to talk about that first. So commenting your code. One of the problems I always have, and I think I put this in all of my assignments, is also don't over comment. I think commenting is important because it helps people understand what you're making. But you also don't want to add comments because your code is terrible and you're commenting so that people understand what you're trying to do. Like as in your code is it's kind of a mess, and you're like, well, this is what my code does, and there's a page of comments for 5 lines of code. Please don't do that either. Okay, that's pretty crazy. I know there's this misconception. Sometimes I think of it that way, as the code is going to document itself. Okay, yes, I think if you're an experienced software engineer or a lead engineer, you can look through pieces of code and go, okay, I get what's happening here. As an example, it speaks to me. You can do a 5-minute read through or pass through somebody else's project structure and understand what's happening. If it's a project that's fairly straightforward, but as you get into more complex projects, you're going to see that commenting and documentation is super important. It's just that you don't want pages and pages of it. So when you're working on the project this semester, try and document the stuff that makes sense. From a more best practices, the way we write our code is important too. Now, I mean, sometimes you get into this kind of like nested hell that this looks like, to be honest with you. You know, an if, else if, else if, else if. And also, sometimes you can get to the point where you can look at some of the code afterwards and go, wow, I wrote some really brute force code, like really terrible code. And that's the time you go back and go, can I simplify? I think in my brain, when I'm writing code, I always think of myself, if I'm repeating myself a bunch of times, if I see myself repeating the same lines of code, like copy pasting a bunch, in my mind, that is a signal for me that later on I need to maybe make a note or something and come back and fix this code. It works, but it's ugly, and that's okay. But I need to go back and fix it because it's probably inefficient too. If it's ugly a lot of times like this, there might be a way of making it better. Okay? So a couple of things. Naming conventions are important. For example, deciding whether you're going to use camel case as an example for your for variable names or parameters. Are they going to use an underscore for parameters as an example? Or are you going to use M underscore for a private member variable? These are things that your lead software engineer is going to have to kind of put together. So I highly recommend, if the lead software engineer in your team hasn't done it already, ask them for a style guide, at least at the very basic levels. Even if they point you to one like Google style guide or IBM style guide or Microsoft style guide, there's tons of them out there. Adhere to one standard is what I'm saying when it comes to coding, so that everyone codes in a very similar way. Okay. And every design house you go to, if you're going to go to a coding house like Ubisoft as an example, they might also have their own style guide that they're going to impose on you, saying things like, hey man, make sure that you put an M underscore P when it comes to a private member variable that's a pointer, right? As an example. They might get even more detailed than that. It really depends on the coding house. So one of the things that when we start coding is thinking about ahead of time planning for maintainability. Okay, so when you start writing code, don't just make it for you necessarily. Think about your team. Think about, are they going to be able to understand the type of code that you've written? And also, think about using repositories. Okay, I'm going to get back to this now. So, how many people or how many software engineers out there, people who are coding, how many people use GitHub? Check mark for people who use GitHub today. All right. How about, thank you for that. For people who are using, I'm just going to clear that up. How about people who use Perforce? Anyone use Perforce? So Perforce is another kind of version control system. I have to tell you that Perforce, thank you for that. No one answered, which means no one uses Perforce. Perforce is the system that is used most often in game development over GitHub. Now, the reason why we don't always adapt it so easily is that, thank you for that, Matthew and Daniel. If you think about Perforce, let's look at Perforce 1 second. Perforce for a while was not free. Okay, so again, I'm talking about kind of software that has been used, and Perforce has a different paradigm than GitHub. So GitHub, you make a commit and you have a repo. Perforce, you make a commit and you have a depot. And you might say, who cares? Repo, depot, same. Yeah, no. Perforce is a lot different. In Perforce, you can lock your files when you're using version control. In GitHub, one of the biggest challenges that you're going to see in some of the later slides is merging. Right? When I have a piece of code and more than one person is working on it, we have things happen to us like merge conflicts and that kind of thing. And it doesn't happen as often, as an example, with Perforce. Okay. Also, Perforce is private and GitHub is on the cloud. And a lot of game companies don't want to share their intellectual property, so they either employ a homegrown or kind of company-based server where they store their stuff, right? So it's in-house. They don't share their code, typically their code base outside and on GitHub as an example. And so that's why Perforce is so popular. And for other reasons as well. So again, one of the things is when you don't use version control. I know some people, for whatever reason, they would rather use Google Drive. Let's just use Google Drive is the thing. I'll put it up on Google Drive, my build, and you can download my build from Google Drive. Guys, don't get into this habit. It's not a great habit to get into. Yeah, here's my version 1, my version 2, my version 10, my final 1, my latest. How do you know which one has what? You don't know. And a lot of times we go, is that the latest build? Is it version 4? Is it the Athena build? Is it the, whatever build you're going to name it? Because people can get very creative with their builds. And you don't know which one is which. And eventually what happens, and it happened to us, okay, we have build 0. It happened to us where we were sharing, we're using Google Drive because, sometimes GitHub is challenging to use with Unity until we found Unity Colab, by the way. We started using, Google Drive as a backup. And unfortunately what it did was it ate us up, right? We had a build that was working on Google Drive. We downloaded it. Someone changed something, and then suddenly no one could use that build anymore, right? So please steer away from using things like Google Drive or passing around a USB when you're closer together, when you're not remote like this, okay? The next thing is be agile, and I think this is a really great thing. We just talked about it earlier today when we talked about things like, hey, you should be using agile methodology, right? So things like, a Jira or a Trello, and again, I highly recommend Jira. Producers, whoever you are, please, I urge you take a look at that. Take a look at Jira. Sometimes, though, I have to also say, and this is the experience we had in our team, that we don't want the project management tool to get in our way of producing our game. Sometimes it can be so heavy duty, like Jira can do that sometimes, depending on how far you want to take it, where your documentation for every one of your issues or your user stories, as an example, it just it can suck the life out of you in terms of actually producing your game. You don't want it to go there. You want to strike a good balance between, hey, here's what I got to do. I've got it done. Now I'm testing it, right? Okay, finally it's off of my backlog. It's not in the backlog anymore because this feature's been completed, it's been tested, and we're happy with it for this release. Okay, so you can see that Agile it takes an iterative approach, to project management. And I'm going to go back to our participant panel here. Who is comfortable with Agile project management? Can you please put a check mark if you're comfortable? I want to understand kind of your level of comfort here. Okay, I got one, and they took it away. Carter was like, yeah, I'm kind of comfortable, and then they put I'm not really comfortable. Or maybe you're comfortable, but we got a couple people down here. So Kaylin, Kennedy, it looks like, Logan, Matthew, you guys are all comfortable with Agile. That's kind of what you did last year. Thank you for that. I'm just going to clear that up. Your Agile project management professor, whoever that was, you should have already learned in your project management course by now. You should have had Agile, or you should have been exposed to it by now. And there are some great tools that you can learn how to use, not just Jira and Trello, but also things like brainstorming tools. So when you're starting to formulate a game, before you even start with your first sprint, before you even start with any of your pieces of your backlog, start doing some brainstorming. And that might mean a brainstorming session when you and your team go away and start thinking about this stuff. And then think about it from a 2 to 4 week iteration process. And for us, because we're at university, it's not 4 weeks, it's 2 weeks. If you can't build a feature within 2 weeks, take that feature out of your game for this semester. Don't include it, right? Or maybe what you want to do, it could be a bigger feature that you build up over several iterations. but then plan for it to come into the game later on. Okay, so so think about it from that perspective. All right, so agile project management. Version control is interesting. There's different kinds of version control. So here, it started off a lot of times, and it's kind of gone full circle, where version control was only local, as a good example. All right, so that means that I have my computer, and or I was on a server. I would go on a server. I would code there, and all my code would have to be on the server, right? So it was local, and then later on, it became difficult because not everyone back in the day had access to a terminal, a computer, right? It was too expensive, and computers were massive, right? And then as things evolved, when everyone had their own machine and stuff like that, it came to the point where we had these issues. I have my code, and again, there's different reasons to use version control, but one of the reasons is collaboration. I want to collaborate with you. Again, I would say if I was going to ask you on a test, hint, hint, if I'm asking you on a quiz, maybe next week, right? And if I was going to ask you the 3 reasons why you want to use version control, you should answer collaboration, backup, and revision control. That's the 3 reasons why you want to use GitHub, all right, or any kind of version control system. Why did I say revision control? Is because you're going to make revisions to your code. You're going to be, or sometimes it's also called source control, where you're controlling your code source, right? So that way you know which version you're in, okay? You know that you're in version 1, and what did you do? Every time that you go up online and you add a feature to your code, you create a snapshot, and we call that snapshot a commit, okay? We create a snapshot, and once we create that snapshot, right, it captures your code at that particular point in time, right? So we can always go back and revert back to that previous, snapshot where you were before, okay? And the great thing is when you put it up on GitHub or another cloud service, GitLab is also another option, as well as Bitbucket. And now all of them have private repositories, and I highly recommend when you're making your game, you use a private repository. Get used to doing that so you control your intellectual property a little bit, okay? But this idea that we're going to capture a snapshot of my code is really, really important, so I can go back and I can see what we did. How did it work before, and suddenly now it doesn't work. Sometimes that becomes like finding a needle in a haystack. I don't know what broke my code. I broke my build, and I hear that from students sometimes. Tom, I broke my build and I don't know how to fix it. Can you help me? Do you have version control? Have you tried to slip back? How are you using version control? Some people use version control at the last minute because I've asked them to. So in your assignment requirements, you're gonna have a requirement for a GitHub link. All of your assignments are gonna have that in this semester, okay? And you're gonna say, yeah, here's my GitHub link. And some of you may just do it the last minute. So let's say on Friday night when it's due, you're gonna go up on GitHub and put it on GitHub. That's not version control. That's a backup. Version control is us working with the code throughout the development process. When I add a feature, I take a snapshot, a commit. When I add another feature, I take another snapshot, a commit. When I revert, I take a snapshot, a commit, right? And all that kind of stuff. It goes on like that. It's an evolving process. So again, one way you want to choose different version control systems, and again, I've mentioned 2 of them, Perforce and GitHub, or Git in general. Git and Perforce are not the same. There's a totally different way of doing things, right? Again, one is more centralized than the other. One is more distributed. GitHub is more distributed. I would say Perforce is more centralized. There's more control with Perforce, but it's also a little bit harder to use. Okay, yeah, I know people don't use SVN as much as before. To be honest with you, that has gone by the wayside. SVN and in general, Subversion, if I'm not wrong, it's been deprecated over the last little while. They've started not to use it because of DevOps is also something that's been coming up a lot lately, and Microsoft, as a result, bought GitHub, which is part of the reason why other version control systems have gone by the wayside as well. So again, other features to keep in mind: backup and restore, short-term undo. One thing that GitHub has, which is also an alternative to Jira, into to Trello is GitHub Projects. So I'm not sure if you've seen that at all, but GitHub Projects, it's a free way of doing things with GitHub, and you can create issues that connect and link right to commits, which is definitely another way of doing things. So take a look at, if you're interested, GitHub Projects, which is another way to use, and they have boards just like Trello, and a little bit looser than Trello, and to be sure, not the reporting tools aren't quite as there as in Trello, or never mind Jira. Jira has amazing reporting tools, but if you want to start going for free, GitHub Projects are the way to go. All right, I like this. I always like this picture, which is the teamwork and how projects really work, how the customer explained it compared to what the customer really needed, right? And this whole map of what project management looks like. And if you haven't seen this right now, or up until now, it's kind of funny, but I've seen it a bunch of times in different presentations. So we talked about why version control, and now there's a couple things too. Some people prefer to use tools for version control. We're going to be talking about version control this semester in general. One of the tools people use is command line. So for example, let's suppose I have a project here. I'm just bringing up Visual Studio 2019, and I want to make a new repository, right? So I want to make a new project. I want to make a Hello World project as an example for with C++. One day when my Visual Studio decides to do what it's supposed to do, then I can choose, there we go, then I can choose a console app as an example. Here's my console app for with Visual Studio, right? And in my console app, I'm going to make a Hello World project. So let's choose a place to put it on my desktop. As an example, I'm going to put it inside of a INFR3110 folder. As an example, here I am, and let's just put this in there. I'm going to call this project my Hello World project. Yay, Hello World. Right, and I want to put this in there. Let's not put the exclamation mark, just from a compatibility perspective, and click create. Okay, so there I am. So there's a couple ways to manage my repository with this project. One way is I could use command line. So here's one way. I have my little Hello World source file right here. Let's just rename this thing to main. So, you know, as an example, so I'm going here and just rename it. So we're going to go rename. And by the way, again, just like Nicholas said, if you don't have access to ReSharp or C++, get it. Totally worth it. It makes your life a lot easier, right, as an example. So let's say I want to capture my first commit of this Hello World. First of all, we run it for the first time to make sure that it works, and it should work out of the box. Should. Right? You should get a nice Hello World up there. Yay! We're Hello World. Awesome. And you want to, you know, get a snapshot of this code. And how would you do such a thing? You could use git commit. I like that, Steph. Let's try that. But how would you do it here in Visual Studio? Well, you could go right-click, and you're going to go back to Open Folder in File Explorer. And when you do that, it'll bring up your folder here. There it is. There's my little project. Notice that I'm my Hello World solution, and I've got my Hello World project in there. And this is where your Git initialization should go, right in here. So for Visual Studio, one of the options you have is I could bring up command line, right? So here's my command line. I bring it up, and then what I could do is go CD space, and then I could take my Hello World project and drag and drop it into my command line like this, right? And then present it, right? And if I do that, I'm inside my project right here. So I don't have to put in my path. That's a real pain. And then I can start, first of all, I got to check to see if my my command prompt even has Git installed. In order for you to install Git, there's a bit of a process. But let's just say Git ---- version. So this is the way of doing it. If I can spell a version, that would be good. Git ---- version. And it's going to tell you that my Git version is 2.27.0 for Windows. Try this at home now that you're there in front of your machine. Chances are most of you are going to have unrecognized command, right? Because Windows, by default, does not have Git installed. However, if you're a Mac or Linux user, it's working no problem right away, okay? But however, there might be a disadvantage for me doing it this way. If you're not comfortable with command line, this could be quite daunting. You might look at this and go, oh, wow, I have to remember the commands. So I would have to do something like this. Git init, right? And what git init does, as an example, notice what it did over here in my my project, it actually added in a hidden .git folder. That's what it did, right? And that is where I'm going to keep track of my commits, right? And then I could do something like, okay, after I've initialized, so git init is the first command, I could say git add dot. Git add dot basically says, and I'm getting a permissions denied. Let me just make sure that it's correct here. Yeah, it's because on my command prompt, a lot of times, this is one of the issues that we have as well, is you have to have the proper rights, right, to do so, right? So if I do a dir, you can see that I'm inside of here, and it's giving me permission denied because, guess why? I'm actually running Visual Studio, and some of my files are locked, right? And that's what Visual Studio does. So what's a better way to do this, right? Well, you can do it through Visual Studio itself. So let's bring this down. We can remove GitHub always from a project by just going into the project folder and right-clicking into the hidden .git folder. By the way, if you don't see this hidden .git folder, if you go to View in your folder, in your File Explorer, and if you click on or off hidden items, you can see this hidden .git folder, right? Commander's pretty good, absolutely, but you can get off by doing this if you really want to. But here, if I right-click and I delete it, so if I want to delete the GitHub folder right here, then now Git is gone. It's no longer being tracked on my here at all, right? So it's the far better way to do it is right through Visual Studio. So again, Nick is going to go through this with you a little bit more. But if you notice here, I'm in Visual Studio and I want to track my my project. There's a couple ways. I can right-click here at the solution level, and then what I want to do is create a Git repository. That's one option. The other option is down in the bottom right corner of your screen, there is this Add to Source Control thing. So I'm going to choose this one, this way. I'm going to just create a Git repository here in Visual Studio, right? And then once I've done that, I can go to my Team Explorer. My Team Explorer is another tab inside Visual Studio itself. And if you don't have this, you can go to View, Team Explorer to get there. All right, that's how you get there. And you need to configure it a little bit. So for the first time, whenever you use GitHub, Git and GitHub in Visual Studio, you want to go to Settings. You want to go to Global Settings and put in your username and the email address associated with your GitHub account, this one. Okay? Once you've configured that, then if I go home, so again, I'm inside the Team Explorer tab, go home, I can go to Changes if I've added any changes. Here I haven't. I'm just capturing this for the first time. And then I can go Home, Sync, and then in Sync, if you have the right extension for Visual Studio, and by default, if you go to Extensions, you can look at Managing Extensions in Visual Studio. You'll see the one that I recommend that you use is GitHub Extension for Visual Studio, which a lot of times now comes bundled with the latest version of Visual Studio that you download. However, if you don't see this in your Visual Studio 2019, what you could do is, when you're online, just search for it by typing the keyword Git. And once you do that, it's going to bring up this extension, and you're going to see a little button like this where it says Download. Click on that button, download it. You're going to have to restart Visual Studio. And when you do, you're going to have this little extension right here. The power of this extension is this. I don't have to use a tool external to Visual Studio like SourceTree. I can just click Publish to GitHub. And when I do so, I'm going to get a list of different accounts that I normally use. Here's one, Ontario Tech University, where I'm going to be sharing some of your code. All right, this is where Nick and I are going to share our code. By the way, I own all of Ontario Tech University. I'm lying. I own both Ontario Tech U GitHub accounts as well as Ontario Tech University. I was kind of first to the buzzer for that one. All right, so if you go to Ontario Tech University, I want to make a new repository. I can call this whatever I want. I know, it's the name sniping. I can go through and just type it whatever I want. I can change this to INFR3110U, and we're going to say in the fall 2020 semester, and it's lesson 1. And if I click Publish, then guess what, guys? I'm going to be on GitHub in 1 sec. And this is great from a C++ perspective, but I think the better way to use version control with Unity is Unity Colab, right? I know, eh? I'm the secret admin. I'm going to get in trouble for it is what I'm going to do. All right, so let's see what happens. So if I go to GitHub, and if I go to Ontario Tech University, this one, then you're going to see that now there's my lesson. All right, so there's lesson 0. This is the lesson I did with Nick, and here's this lesson here. which is us, right? And if I go in there, you can see that I have my solution, my hello world, and inside there's main. Okay, so there's my little hello world program, which is completely useless. Make sense? So you can do that all within Visual Studio. You don't have to go outside of Visual Studio to do version control. Okay, that's my little dog and pony for today. Let's go back to this. So why do you use version control? Like I said, collaboration, backup, and adding features to your project. Tracking features. Feature tracking. Call it what you like. One thing to know when we use any kind of version control system, you want to use a descriptive commit message. So something like added health bar for player is a good message, right? But the other thing you can't do is you can't make that message too long. In fact, a lot of times, if you try and make a message that's too long, what's going to end up happening is, the GitHub will complain. It's going to say, you know what, your message is a little bit longer than we'd like. It's going to be truncated. It's going to be cut off. You won't be able to see the entire message up on GitHub. So don't make it too long. Make it so it's descriptive, but short enough that you can quickly understand what it means. Okay, that's kind of a best practice. Indiscriminate commits, like updated project, doesn't mean anything. Okay, make sure you know what you're updating. If other people are working with you, incorporate their changes as frequently as you can, as long as it doesn't break your build. Be careful about that. And the idea of, not breaking your build, especially before JamesCon or before reviews with James and me, right, which is happening, it can happen at any time, guys. It's easy to break your build if you're not careful. So have a backup. And what I mean by that is use features, feature branches, all right? One of the things that you don't want to do is make a name branch, the Tom branch, the Daniel branch, the Adam branch, the Anthony branch, the Steph branch. Don't do that. Better to do this. Better to say something like, I'm adding a feature. My feature is my health bar. My health bar branch is what I'm putting in. That makes sense. I'm doing a bug fix branch, because I'm fixing this bug, whatever the bug is. That makes sense. But don't do just random branches for no reason. Okay, so that's something that we want to think about. So the way it basically works is like this. You've got your main trunk or your master branch, if you will. And now here they have an example with milk and eggs. Okay, and again, this comes from GitHub, Better Explained. But more or less what happens is, you want to start off at revision 1, you just add milk, right? And then I want to add eggs. And then I want to add juice. And then I want to add soup, as an example. And you can see that I got rid of juice and I added soup here. So this is my 4th revision, or my 4th commit, if you will, that's coming in. So this is how it works. It's additive in some ways, or it's an evolving process when you use GitHub, okay, or any kind of version control system. Checking out, and a lot of times the checkout system, remember, checkout is for per force. GitHub doesn't use checking in and checking out necessarily. You could use it that way, but that's normally not how it's like. A checkout system is usually where I lock a file that I'm working on. I check it out because I'm locking it. For example, here's my working copy of milk, eggs, and juice. No one else can touch this right now and update it because I'm working on it. And then what I do is I check it back into the main trunk. That's not how GitHub works. This is how Perforce might work, where you're checking it out, holding on to it, locking it, and then putting it back, okay? Again, when I ask you questions like this on your midterm test, right, you should be able to understand the difference. When you look at this diagram, you can look at it and go, that's not GitHub. You should see it and understand that this is not GitHub, okay? And by the way, the videos are going to help because you can be able to look at the video and hear what I'm just saying. Here's another one. When I do diffs, so what is a diff? I want to compare one commit with another, and you can do that up on GitHub. So let's take a look at what a diff would look like on GitHub. Well, for every one of these commits that I do, so let's say if I want to look at my Hello World project, here's my lesson as an example. And if I look, there's 2 commits that I've made here, right? By default, Microsoft creates 2 commits for you. One where it adds a git ignore and a git attributes files, those 2 files. And the other one when I add my project files for the first time, okay? So let's add another thing to my project. So let's say, for example, I go back to Visual Studio. Let's go back to this. And let's bring up Visual Studio one more time. I probably should not have closed it, but it's okay. Actually, there it was. It was right there. Let's just double click on my solution and bring it back up. So if I go back to Visual Studio and I add a function as an example for to say hello or something else, or maybe I want to, it's going to be my function, my welcome function, we'll call it, right? So again, it's going to be returning void. It'll be called we'll call it properly, we'll name it properly, my welcome function. Let's suppose that in my coding house that I'm going to use upper camel case for my code. Let's suppose, right? My welcome function. You can see how in some cases what's happening here, by the way, is with the reason why it's taking so long is because of resharper, right? So my welcome function is pretty useless. All it's going to do is a standard cout, right? Where I'm going to say something like, hey, welcome home, hey, welcome to the course, right? And let's put in a standard end. By the way, I totally am against using statements as much as possible. That's just me, only because you can make your code more cross-platform compatible. All right, so I want to use my welcome function here. So down below here, I'm just going to call my welcome function. There we go, right? And hey, I made a change to my project. It's not a great change. I should test it. Let's run it and see if it even works, right? Who knows if this is going to work? Tom, right there it does. And now I have something I can change. So I'm going to go again to changes, right? Notice now I have the file that's been changed. It notices this. And I can enter a commit message. Added my welcome function, right? This kind of stuff, right? Commit all. And then I'm going to go to home. I'm going to go to sync. And I'm going to go to push. Home, sync, and push. You're going to get into that rhythm all the time. Now that I've made that change and it's up on GitHub, so if I go back to GitHub now, here I am back on GitHub, and if I go back to my project, notice that I have 3 commits. So now I can start thinking about my code. If I click on the commit itself, these are different commits here. If I click on this one, it's going to give me a diff. This is what it's talking about. Anything in green is an addition. Anything in red would be a subtraction. A kind of an omission. I've taken it out. So this is the diff. It's showing you what I've added this commit. Okay, as an example. So that's what this is explaining here in this PowerPoint slide. It's making diffs. I can compare things that I've added compared to things that I've removed from each of my commits. It's an important skill to look at. What broke my build? Take a look at your commits. What did you do? What did you remove? What did you add? That's how you can figure it out a lot of times. Branching is interesting. We talked about branching, and if you don't know about this, a lot of people don't do enough branching in their code. They work off the master branch, which is also not recommended. We want to come off of the master branch. So let's say, for example, I'm at revision 4 or commit number 4. I come off the master branch. When I do so, right away, I've got a copy of the master branch in the beginning, right here. This is my copy. And then I do some kind of addition. I add rice as an example in this kind of example, right? So now I'm still off the master branch. I'm actually ahead of the master branch when I'm here. But then suddenly someone adds something else to the master branch. Another revision here. Milk, eggs, soup, and bread. Guys, question for you. Let's look at the right side here. Check mark if you think there's a problem here. X if you think everything is good. What do you think? Do you think there's a problem? Put a check mark if I'm going to try and merge this back in. Okay. Daniel, you were quick to the punch. And I got some other people. Jonah, you think it's a problem. Christian, Logan, and Mac. You know what, guys? You're right. There's a problem, right? Thank you for that, by the way. The way it looks right now, if I was to try and merge, right, or take this revision 6 and put it back onto the master branch, or merge it back onto the branch, I would have a merge conflict. Why? Revision 6 is not compatible with revision 7. Because it didn't come from revision 7. It came from revision 4. That is the reason why it happens. I came from here and I made this addition. I didn't know about this. So when I merge this back in, I'm going to have to think about what am I going to do with bread? This other file here or whatever this feature is. Do I merge it? Do I get rid of it? Is rice better than bread from a feature perspective? I don't know. Does it even make any sense? Are they compatible? Can I just merge and not worry? These are all questions you're going to have to deal with when you do the merging. So here's the merging idea. I've added rice. Here I've added bread. I want to take rice and add it back in, and I want to merge nicely from this feature branch, this R6, into R8. I make a new commit, a new snapshot of my code, including both rice and bread. That is easy to do. If both things are not being worked on by the same people, we can make that merge, no problem. It's when you get into merge conflicts that's a problem. Conflicts can happen if, for example, you start at a revision, you move to add additional products, and then someone else makes a revision as well of the same code that you're looking at. Now you're in trouble. Now you got to figure out, which version do I take? Do I take the feature branch, or do I take this feature branch? Which one do I take? And you have to do conflict resolution that way. And once you've done your conflict resolution, you can decide what your new master branch is going to look like. Which features am I including? These ones or these ones? Sometimes both, but mostly either or. Okay, as an example. Okay, and Visual Studio has those tools, but there are really great additions and extensions you can use with Visual Studio to make your life easier, right, when it comes to branching and merging. Okay, and we'll talk about those things in tutorial. Nick will go through some of those things with you. Any questions before we get into OOP review? Any questions around version control? Guys, I'm covering it because it's going to be on your test. I'm covering it because you're going to be required to use version control in every assignment that you do with us in this semester. All right, because it's something that developers do. And guys who are, or girls who are not used to it, people who are non-programmers or people who are less of a programmer than you are, more of a technical artist or a producer, you need to know how to use it because your team is going to be using it, chances are, somewhere down the line. You need to understand it. So don't shy away from it. Embrace it. There's some great tools out there if you don't want to use Visual Studio, and some of them are source tree. Okay, I'm going to talk about some tools here, and Nick will talk about the ones he likes. So this is source tree. I'm not really a fan of source tree. Some people love source tree. They're like, source tree is awesome. It's cool. You've got a really cool visualization about your commits. Yay. Okay. I mean, if I'm going to use a visual tool for Mac and Windows, maybe this one. But I actually prefer Gitkraken. I think if you're going to use a visual tool, then use a nicer looking tool. And I think Gitkraken, if you're going to use some kind of user interface, it's going to be this. But I can tell you, most often, guys, I use command line 9 out of 10 times. Okay. And if I need to, especially when I'm programming on the web, if I'm doing something like a web-based game or anything to do with web, it's command line, right? Or Visual Studio Code. If I'm using C++ and I'm using Visual Studio, I always try and use my tools built into my IDE, which is Visual Studio's GitHub extension. If I'm using Unity, I'm using Unity Colab, all right? Because that is the way to go with that. And you can combine Unity Colab with, as an example, here's Unity Collaborate. Unity Colab is great because it allows you to use Unity, and it doesn't make each of your scenes atomic. One of the biggest problems we have when we're coding in Unity is our scenes are atomic. You can't actually, if I work on the scene and you work on the scene, we break our build right away, right? But Unity Colab helps you with this. And Unity Colab is free for up to 3 people, right? So you can buy a license. I think it's $9 per user, that you want to use. So for 6 users, a team of 6, again, and this is per month, by the way, per month billing. So it's not cheap. It's $20 a month, kind of stuff. Or sorry, more like $30 a month. $30 a month US, right? But the great thing about this is it allows you to do quick development. Guys, I'll tell you right now, Unity Colab saved us when we were building Manos returns. Okay. GitHub Desktop is really nice too, but again, when it comes to, think about Unity as well, Anthony. Any one of these tools, Gitkraken, or if you're using SourceTree or Visual Studio or whatever, think about the use case. The use case that you're going to be facing this semester is Unity. Think about Colab. Colab might be the way you want to go. Okay, and I'll get Nick to talk about this in. I'll get Nick to talk about this for you guys in tutorial. Okay. All right, so that is kind of the end of our discussion on version control, I want to move into OOP a little bit now. And we're going to talk about what makes up OOP. What is the good parts of OOP, the good, the bad, and the ugly. Let's talk about those things, right? There's really good parts of using object-oriented programming. Huge, right? Especially when you're making a small game. Object-oriented programming might be for you, right? But as you get making bigger and bigger games, object-oriented programming becomes hell. And we're going to talk about this. So the 4 parts that are listed here: abstraction, polymorphism, encapsulation, and inheritance, as well as information hiding. That's what encapsulation is a lot of times. All those, call them principles, are the things that make up OOP, or object-oriented programming. When we think about terminology for object-oriented programming, this is a review for you guys. Again, you've been away, some of you for all of the summer, and some of you who are not programmers or who are not as comfortable programming as others, may have forgotten some of this stuff. So this is my chance to review it with you. And again, Nick is going to go over this stuff with you in tutorial a little bit more closely. You'll have a chance to do some more practice than what I'm showing you here. Okay. But an object is really an instance of a class. Think about it as, I want to breathe life. I'm a DM and I want to add enemies to fight my players. Every time I have an enemy come into the scene, I'm creating an instance of that enemy. I might have the monster manual. My monster manual might be everything that I want to add in, to attack the players with. But I'm going to create instances of those creatures that are listed in the monster manual. Those are my blueprints. Those are my classes of creatures. And I'm going to include them inside of my game as an instance. That's an object. Okay? Well, to me, this is me. I love D&D, right? And for you guys, you're going to use your own analogies for some of this stuff. Class. So what is a class? To me, a class, if I was going to think about creature again in D&D, a class is like a creature in the monster manual. You have properties of that class, or you might have attributes of that creature, different kinds of strength, dexterity, constitution, wisdom, intelligence, charisma, whatever you have in there. Those are some attributes, as well as some capabilities, skills, behaviors that that creature can do. Something like, for example, maybe they can breathe fire. That's a behavior, a method, right? As an example. Something that they can do. And that class is a blueprint for me instantiating, or instancing, sometimes it's called, creating or breathing life into the creatures that I put into my D&D game. Okay? So that's kind of the same way that you can think about it when you're coding. You have this monster that you're making, all right? In this case, it might be something like, your player, right? And you want to instance that player from one scene into the other, right? As an example. Okay, so basic terminology. Again, definitely, if there's a chance to put stuff on the test, these kind of things are things I might put on the test. Okay, what's the difference between classes and objects? Well, remember that if I have an enemy class, it's a blueprint for other enemies. I could have different kinds of enemies, right? But coming from the same enemy class. So these could be instances. Each of these enemies, Koopa and a Goomba, they're instances of my enemy class, okay, as an example, okay? And there's different kinds. You can have different versions. You can have a further subclass. So example, this one, Flying Koopa, can be a subclass of the Koopa class, all right, as an example. Or it inherits from the Koopa class. There's actually, what's happening here is an inheritance chain. You start off with the base class or super class, or parent class, you can call it different things, all right? And then you have a child class or derived class, as an example, or subclass. They all mean the same things, by the way, these words, okay, for the most part. And then what you can have is a further subclass. Each subclass of the base class is a specialized version of the class before it. I want you to think of it that way. So, and also, which is different in real life than it is when it comes to coding, all children, okay, I want to tell you this, guys, right now, so you can remember my words. All children are fatter than their parents in programming, okay, when it comes to programming. Why? They have more specializations, right? So because they have more specializations, they have more features, they have more methods, they have different properties, in addition to what the parent has. This way, they are fatter. Their footprint from a memory perspective is bigger than their parents. So if I have several classes inside of a hierarchy, then Flying Koopa, because it has the flying capability compared to a regular Koopa, is fatter in terms of code, memory utilization, and its footprint inside of our game engine than a regular Koopa, or even an enemy class itself. This is good, but it can also lead us down into a bad path, and we'll talk about that in a bit. It's good because it makes sense for us. When we look at this, we're like, yeah, we can make as many of these as we want. It's bad because once we start going down the path and we make more and more specializations, well, we have some inefficiencies happen. And there's some class examples here that are included. You can have things like, different kinds of states, if you will, that are part of every class. I'm not going to go into this too much. Let's get back into encapsulation, what this means. So encapsulation, this idea means that I want to hide features of my class. I want to keep things private. In my mind, whenever I think about object-oriented programming, I'm thinking private member variables, public properties. And some junior programmers will say, I never need to use a public property. I can always use a public member variable. Guys, get out of the habit of doing that. Because a public property, in your mind, you should think about it as a getter or setter, is a method. If I can use a method, then I can do something when I'm setting a value for a data member. I have a data member, I want to set a value to it. Let's say I got a health data member. I want to set a value to my health data member. It's going to go through my set health method as an example. I'm not going to access the health property itself. Why? If I set health, maybe I can at the same time update my health bar, right? I can track that health has been updated through a logging system or something like that. If I directly access the member variable, I can't do that, or it becomes more challenging to do so. So encapsulation is pretty awesome because it hides the details. It's like your class is a black box. No one understands what's inside of it. You understand what's inside of it. It's a Pandora's box a lot of times with bad things that can come out of it. But you give the user of your class only enough information for how to use it and nothing more. Encapsulation, which is information hiding. Okay, I'm going to keep going. This is an example of a UML diagram for a class. The class name is at the top. We're going to go more and more about this later on in the semester. Then we have, in here, we have our features, if you will, or our properties. And down in here, these are private member variables. And down in here, we have public properties, right? And a private public constructor. Notice that's the same name as the class, which has a plus next to it. Plus means public. And we can see here that we have two public methods, a name method. Actually, this is actually a getter and setter. This is a property. And a public age property, okay, which is returns a time span. Okay, so we'll go into more of this in UML. We'll talk more about this and how to use this to make our lives a lot easier. Okay. I'm not going to go into the code too much. We're going to talk about that. You're going to be talking more about that in Nick's tutorial. Inheritance. We talked about inheritance briefly. We have an enemy class, and Koopa inherits from the enemy class, the enemy superclass. And Goomba also inherits from my enemy superclass. But guess what? Koopa and Goomba have nothing to do with each other. The only commonality is that they have an is-a relationship in your mind. Whenever I say Koopa is a enemy, and so is Goomba. Goomba is a enemy, but Goomba is not a Koopa. They're different, right? Because they have different specializations. However, you can say that a flying Koopa is a Koopa, and a flying Koopa is a enemy class. Enemy, right? That's how you classify them. So whenever we think about inheritance, I want you to think about a is-a relationship. It's an is-a relationship, okay? And sometimes we also think about inheritance as something, we say things like it has a certain feature, okay? Whatever that is. So there's an inheritance example here between the enemy and the Koopa class. I'm not going to go into that again. Nick is going to go into details about this when you see him in your tutorials. Okay, I'm going to skip down here. It says modes of inheritance here, but I like to think about this as access specifiers. Whenever we think about accessing a member variable or a method, we can protect it in three different ways. We can assign a public access specifier, a protected access specifier, or a private access specifier. And what I mean by that is inside of our class, there's different places or different areas in C++ where you can specify public, protected, or private members, right? In C#, it's different. And this is where Nick is going to talk to you guys about the difference between C# and C++. In C#, it's not like this, in fact, right? Everything in your class in C# is one, right? Typically, you don't separate your interface, which is the public, private, protected areas of your .h file, as an example, from your class in C#. It's all one. And you actually use public, private, and protected keywords in front of each individual method or member variable in C#. Okay, it's a lot different than this. And what's the difference between private and protected? People should know what this is. A private member variable or method is only accessible by the class itself, right? Whereas a protected member variable or method is also acceptable or accessible by the subclass of a particular parent class. So that's the way it works. Again, Nick is going to go through the coding with you and to explain how this works. I'm going to skip over two types of inheritance. Typically, what we like to see in industry, and I'm talking about in, whether you're in the game industry or you're outside of the game industry, is single inheritance. Single inheritance. Why? It's easier for us to consume the idea of single inheritance. Why? Because it's easy to say I have one parent and child. Multiple inheritance, we have this problem of this deadly diamond idea, this problem here, where I have a parent, as an example, and each of the children have the same method that's inherited from the parent, and they also have their own specialized methods called the same thing. Let's say, for example, speak. I have two methods called speak. And my child, this child here, this subclass, inherits speak. Which one does it inherit from? From child 1 or child 2? Don't know. And this causes something called a deadly diamond, which can be a problem in multiple inheritance. So a lot of times multiple inheritance is discouraged among junior programmers, people who don't know what they're doing. But it can also be used effectively, especially when thinking about things like a system where you want to be more flexible, right? And I want to include methods from two different types of classes as opposed to limit it to only one class. Be careful about this. Advantages of inheritance are it promotes reusability. Okay, that's the main thing. It allows me to create a hierarchy of inheritance, which is very visual, and it speaks to a lot of programmers. I can look at it and go, okay, I get what's happening here. The disadvantage of it is what we talked about before. Classes become huge, and objects of those classes become massive. Massive. They're huge. Imagine making a game object as a superclass, and the subclass of that game object is the actor class, and the subclass of that actor class is an enemy class, and the subclass of that enemy class is a specific type of enemy class, and so on and so on and so on, until the enemy that you're working with, which is in a huge inheritance chain, is massive from a memory footprint perspective, really slow and not performant. And this is the impetus, if you will, of making something like an entity component system, which is not using inheritance at all. It uses composition, which is basically another way of doing things. All right, so that is inheritance disadvantages and advantages. Polymorphism, just like, and I'm sorry, I'm a Greek guy, so I got to say this one time with you guys. It's Greek, right? It's poly. You guys are going to laugh at me now. And morphi, which means many forms, actually is what it means. Poly or poly. And morphism is many forms. That means that I can take a method and I can override that method. If I'm overriding a method, I'm using polymorphism. If I'm overriding an operator, I'm using polymorphism, guys. That's overriding. Any kind of overriding or overloading is usually what I'm doing when I'm using polymorphism, and it's usually happening from an abstract class a lot of times into a subclass. So that's what polymorphism is about for the most part. Let me skip down into, again, like it says here, function, it's very bad the way it's written here, but function overloading and operator overloading are two examples of polymorphism. We also have inside of C++ something called virtual methods, and same thing with C#. They have the keyword virtual. One thing that C# has that that C++ doesn't have is this abstract keyword. In order for us to create an abstract class in C++, we need to make a pure virtual happen with, especially when it comes to our virtual constructor, or sorry, destructor, right? Which is a lot different. Once I have one virtual method, as an example, or a method is pure virtual inside of a class in C++, the whole class is considered to be abstract, right? Whereas in C#, what we want is to use the abstract keyword. And that doesn't exist in C++, but you're going to see that as a feature of C#, all right? The idea of the abstract class, before we move on, is this. If I make an abstract class, it's the blueprint of blueprints. I'm never going to create a class like enemy. Enemy, there's no value, there's no context for enemy. It can mean anything. It's like saying you're a person or a human. Human doesn't really mean much in terms of identifying who you are. And when we're talking about things like in D&D, let's go back to that D&D example. It's a monster in front of me. Okay, what monster? Monster means nothing, right? But if I tell you it's a goblin, now we know what we're talking about. It's a goblin. Which kind of goblin? Okay, that's something different. But I know it's a goblin. Monster is an abstract concept. It doesn't give me enough information. But it's great because if I know that all monsters act in a specific way, and all other monsters derive from or are children of or subclasses of that particular monster, then I understand that all monsters are going to have some kind of capability that are shared, right? So that's where abstract classes make a lot of sense, okay? So again, more polymorphism examples and abstraction. We talk about this idea of hiding the implementation details from the user, but also creating this superclass of superclass, or a blueprint of other classes. Guys, we've really come to the end of my lecture, and I've talked my brains out for about another hour and a half. There's a lot of little references here that you can look at for things like C++ and a lot of other stuff that we talked about today. I guess takeaways from today are this. Please don't forget about version control. Think about coding best practices. Again, I'm going to say software engineers, lead software engineers, the people that are out there. Make sure you come up with some kind of style guide for your people, right? If you want them to code with you, you don't want to be the only coder in the whole group because you're overloaded with work. Help them. Make a style guide for them and let them use version control as much as possible, okay? Get them all involved, everybody. Producers, make sure that you're involved with the coding, not just the documentation and managing the project. Get involved, get your hands dirty, because guess what? Technical artists and producers and designers, you're going to be on the hook for individual assignments that I'm going to start handing out next week, right? So you need to get into this coding stuff. Otherwise, what's going to happen is it's going to hit you. And I don't want that to happen this semester. I want you guys to have a happy semester, to be honest, right? Which means getting your hands dirty and coding every single time you have an opportunity. Guys, that's what I want to leave you with this week. I'm going to stop recording now, and I'm going to take any questions that you might have before the end. And I know we've kind of run out of time, but I'll stop anyway. All right.